So, last section of Chapter 9, percent yield. And we looked at this a tiny bit in lab on Friday. Percent yield is an important indicator of efficiency. And this is especially important if you're in industry and you're trying to make, I don't know, sodium hydroxide or something, and you need to know, how efficient is the process? Am I getting all that I can get out of this process? It's also helpful in lab situations just to know, okay, how much am I going to end up with? Because if your percent yield is 50% and you need to end up with 100 grams of product, that means you better start out to make twice as much to get the amount that you actually need. So we're going to learn how to do some simple calculations with percent yield. So there are different kinds of yield. Theoretical yield is the maximum amount of product that can be formed if the limiting reactant reacts completely. The theoretical yield is what we have been learning how to calculate. When you do a stoichiometry calculation, you do grams to moles to moles to grams and end up with a number, that's theoretical. That is in theory if everything worked perfectly. And there's a whole bunch of reasons and possibilities for why things would not work perfectly. The actual yield is the amount that is actually produced. And that is usually less than the maximum expected. And so percent yield is going to give us the relationship between those. So we express the actual yield as a percentage of the theoretical yield. So here's our equation. We take the actual yield. This is what you measure in lab, okay, and our product is still drying away. It's dried by now, but we'll weigh it later this week. That's your actual yield. You don't calculate that. In a problem, like a homework or an exam problem, they have to tell you what that is, okay? The theoretical yield is what you calculate. So it's the actual over the theoretical times 100, and that's called the percent yield. And the closer to 100%, the more efficient your reaction is. Let's see. Okay, so this is a continuation of an example we did in an earlier lecture. So this was what was given. We reacted 10 grams of A with 10 grams of B. It asked us what mass of product would be produced given these molar masses, and they gave the equation. And we already did that calculation, and we came up with a yield for C of 8.33 grams. This is the theoretical yield. So this guy right here, theoretical. We calculated that earlier. We determined that 8.33 grams should be produced. 7.23 grams of carbon is C, is what was actually made in the lab. Okay, this guy right here is the actual yield. What's the percent yield? Well, we use the equation. Percent yield equals actual over theoretical, I usually call him Theo, times 100%. So actual is 7.23 grams. Theoretical is 8.33 grams times 100%. What happens to those units, gram and gram? They cancel out. They go away. A percentage has the unit percent. It doesn't have anything else going on there. So we get out our calculator, and we take 7.23 divided by 8.33 times 100, and we get 86.8%. And that is the percent yield. That means that if you set out to make 100 grams of C, you'd actually end up with 86.8 grams of C. Any questions? I've seen people in some of my other classes doing some very strange things with percentages, and I don't know where it's coming from. Sometimes they forget to multiply by 100, and other times they multiply by 100 twice. I'm not sure what's going on with that, but I'm just going to warn you against stuff like that. Just take the actual, divide by the theoretical, times 100. There shouldn't be any calculator issues with this equation, and then just write down what it tells you, and that's the percentage. Don't multiply by 100 again. Here's another one. Find the percent yield of product if 1.50 grams of SO3 is produced from 1.00 grams of oxygen and excess sulfur via the reaction 2S plus 3O2 yields 2 SO3. So the words percent yield are highlighted there. I read through the problem. Now I'm going to pick it apart. Percent yield is what they're asking for. Probably a good idea to write down what the equation is. Percent yield is actual over theoretical times 100%. This tells me that in order to calculate the percent yield, I need to figure out what's the actual yield and what's the theoretical yield. So what is this telling me? 1.50 grams of SO3 is produced. That's telling me that's what was actually made. That's what they got. That massive product that's being handed to me is the actual yield. So this is the actual yield right here. That was produced from 1 gram of oxygen. Okay, so I've got this equation here, 1.00 grams of oxygen. I have to calculate the theoretical yield. There's only one product here. What I need is that in grams, and that's going to be my theoretical yield. Is this making sense? So now I need to do a stoichiometry calculation, grams to moles to moles to grams, with this guy. So we're starting with 1.00 grams of O2. We're not using this 3 yet. That only shows up in the mole ratio. Grams to moles to moles to grams. Grams of oxygen to moles of oxygen. To moles of what? SO3, our product. And then to grams of SO3. Grams to moles to moles to grams. And then we put our units in so they cancel out nicely. Moles of SO3, those are going to cancel. Down here we want moles of O2. That's going to cancel over here. And here we need grams of O2. The middle term is moles of one thing to moles of another thing. This is where we use our coefficients from this equation. In front of SO3 is the number 2. So that goes here in the mole ratio. In front of O2 is the number 3. So we're going to bring that down here. We are done using the coefficients. Over here, we're going to calculate the molar mass of oxygen. 1 mole of O2 weighs how much? Well, the formula is O2. That means 2 times the mass of O. 32.00. And then over here, we need the molar mass of SO3. Sulfur is 32.07, and O3 is 3 oxygens. (32.07) plus 3 times 16 equals 80.07. So 1 gram times 1 divided by 32 times 2 divided by 3 times 80.07, there's a 1 down there, divided by 1 equals, I'm going to round that off to 3 sig figs, 1.67 grams of SO3. You could keep extra digits there. It's not going to hurt anything because that's not our final answer. The final answer is the percent yield. This is our theoretical yield. Theoretical means we calculated that in theory this is going to work out and give us that much. Do things ever go according to plan? No. No, they don't. So that's theoretical. I didn't leave myself any room. I'll write above then. So the percent yield is the actual yield, 1.50 grams, divided by the theoretical, which we calculated, times 100%. So 1.50 divided by 1.67 times 100, 89.8%. And that's the answer, 89.8%. Any questions? That question I did from the homework earlier, number 46, that was so ugly with balancing the equation and then messing around with limiting reactants and masses of both products, it could be made even uglier by giving you a mass of product and asking you to calculate percent yield. But I won't do that to you on an exam. Let's not do that one. Your book goes over problems like this where they're giving you the percent yield and asking you to find the mass of reactant needed to make a certain amount. We're not going to do those calculations. That's a little more advanced, and we're just going to stick with calculating the percent yield. So I mentioned this earlier, but I'm just going to go over it again. Oops, my computer's having hiccups or something. Why could there be greater than 100% yields? I don't know what's up with my computer. How could the percent yield be greater than 100? Because is it actually possible to make more than a perfect reaction? It's not possible. It's like, if you've got 2 pieces of bread and 3 pieces of meat and 1 piece of cheese, and that's enough to make 1 sandwich, could you make 2 sandwiches out of that? No, you can't, because stuff doesn't come out of nowhere. So a percent yield that's greater than 100 always indicates that there's a problem. Some sort of a problem. The most common problem is wet product. Now, we made calcium phosphate in lab on Friday, and I know at least one, we were drying it in the oven, and at least one person got theirs to the point where it looked dry. And then they weighed it on the balance, and it weighed a lot more than it should have weighed. It looked dry, but I would bet you money that when we go in there next Friday and weigh that same sample, that it weighs a lot less. Because we are looking at little samples here, around a gram. And you throw a little bit of water in there, and it's going to change the mass a lot. So if your product is wet, then it seems to weigh more. It looks like you made more product than you actually did, and so you can get a percent yield over 100. You could also get contamination. We separated our product from a solution, right? We precipitated calcium phosphate, and then we filtered it. Well, if we filtered it and the solution that we filtered it from contained a lot of dissolved solids, and we didn't rinse those out of our product, then we could end up with sodium phosphate, or sodium chloride, or other things from our reaction that are in our product. And that also will make the mass of the actual product appear to be more than it really is and give us a greater percent yield. Another thing with contamination is something could actually fall in to your product. Doesn't happen very often, but it can happen. So anytime you have a percent yield over 100, there's some sort of a problem. So if you get a percent yield over 100, and it's like, 105, even like 120 or something on a homework problem or an exam problem, definitely check your work, but that doesn't necessarily mean that you did something wrong. If you end up with 5,000% yield, you calculated something wrong, and you need to go back and check, okay? But usually the percent yield will be less. And sometimes people have a hard time remembering, do I put the actual, is it actual over theoretical, or is it theoretical over actual? Usually putting the smaller one on top will work. That's kind of a shortcut. So if you have a hard time remembering, small one on top works most of the time.